Have you ever wondered how your computer operates? What makes it tick? Today, we'll peel back the curtain and take a closer look at the fascinating world of computer systems. At its core, a computer system is a blend of two essential components, hardware and software. Picture a symphony. The hardware, composed of physical components like the processor, memory, and storage, is the orchestra creating the music. Meanwhile, the software, which includes operating systems, applications, and data, is the conductor, directing the orchestra on when and how to play. Together, they create the beautiful melody that we know as a functioning computer. From sending an email, playing a game, to browsing the web, every action we take is a result of this intricate dance between hardware and software. So, it's clear that hardware and software are the two main components that make a computer function. But how do they interact? Let's delve deeper. To understand the interaction between hardware and software, we need to understand their hierarchy. Let's start from the ground up. At the base of our hierarchy, we have the hardware. These are the physical components of a computer system, such as the processor, memory, and storage devices. Without these, we wouldn't have a functioning device. Sitting a level above the hardware, we find the system software. This is the software that manages and controls the hardware. It includes the operating system and device drivers. The operating system is the heartbeat of the computer, managing resources, controlling hardware operations, and providing an environment for software applications to run. The device drivers are the translators, interpreting instructions from the operating system and converting them into a language that the hardware can understand. Next, we have the middleware. This is the software that provides services to software applications beyond those available from the operating system. It can be thought of as a bridge connecting the operating system and the application software. At the top of the hierarchy, we find the application software. This is the software that we interact with on a daily basis. It includes things like word processors, web browsers, and video games. The application software relies on the system software to function and make use of the computer's hardware. So from bottom to top, we have hardware, system software, middleware, and application software. Each layer in this hierarchy has a specific role to play, and each relies on the layers beneath it to function. But what's the key takeaway here? It's about understanding the relationship between these layers. The system software, particularly the operating system, is the linchpin. It acts as an intermediary, bridging the gap between the hardware and the application software, making sure that they can communicate and work together effectively. This hierarchy shows us how system software, like operating systems, bridges the gap between hardware and application software. The operating system is the heart of system software, but what exactly does it do? Let's dive right in. At its core, an operating system, or OS, serves as a manager. It oversees everything in your computer, from the smallest bit to the largest file. It manages hardware resources like the CPU, memory, and input-output devices, making sure everything runs smoothly. This management role is crucial because it ensures that each application gets the resources it needs without clashing with other applications or overloading the system. An operating system also serves as a translator. It takes the high-level commands from the user or application software and translates them into low-level commands that the hardware can understand. This translation function is pivotal as it allows us to interact with our computers using understandable commands rather than complex machine language. But an operating system isn't just a manager and a translator. It's also a bridge. It provides an interface between the user and the hardware. This interface can take several forms, ranging from a command line interface where you type commands to a graphical user interface where you interact with visual elements on the screen. The interface is what makes our interaction with the computer possible and even enjoyable. In addition to these functions, an operating system also handles system security, file management, and error detection. It ensures that unauthorized users can't access your data, organizes files for easy retrieval, and monitors the system for potential errors or failures. So, next time you boot up your computer, spare a thought for the operating system. It's working tirelessly behind the scenes, managing resources, translating commands, and providing an interface that makes your interaction with the computer seamless. It's the unsung hero of your computer system, allowing you to browse the web, write documents, play games, and do countless other tasks with ease. In essence, an operating system is a manager, a translator, and a bridge between the user and the hardware. Now that we understand what an operating system does, let's explore the different types. The world of operating systems is as diverse as the devices they power, and they can be broadly classified into three main types: batch, time-sharing, and real-time systems. First up, we have batch operating systems. This type of OS does not interact with the user directly. Instead, it processes a series of jobs or batches that are prepared and fed into the system. An example of this is the IBM's job control language. The beauty of batch systems is that they can perform massive computations by scheduling jobs when the system resources are less busy, maximizing efficiency. Next, let's talk about time-sharing systems. Unlike batch systems, time-sharing operating systems do interact with the user. They allow multiple users to share the system resources simultaneously, each getting a small slice of the system's time. This creates the illusion that each user has their own dedicated system, when in reality they're sharing it with others. Unix is a classic example of a time-sharing system. Finally, we come to real-time operating systems. These are designed for systems that need to process information and respond within a certain time frame. Real-time systems are essential in environments where a delayed response could spell disaster, such as in flight navigation systems or pacemakers. Each type of operating system has its own pros and cons. Batch systems are excellent for tasks that don't need immediate attention, but they lack interactivity. Time-sharing systems, on the other hand, provide interactivity but can struggle with performance if too many users are sharing the system. Real-time systems are fantastic for time-sensitive tasks, but they require careful design to ensure they can meet their deadlines. To sum up, operating systems are like the conductors of a digital orchestra, coordinating the hardware and software components of a computer. They come in different types, each with unique features and uses, catering to different computing needs. Whether it's processing a large batch of data, sharing resources among multiple users, or ensuring a pacemaker keeps ticking, there's an operating system designed to do the job. Each type of operating system has its unique features and uses, catering to different computing needs. Operating systems can also be categorized based on their user interfaces: CUI, CLI, and GUI. Let's begin with the Character User Interface, or CUI. It is the simplest form of user interface where the user interacts with the computer using a keyboard. Here, the user has to type commands for every task, making it less user-friendly. An example of a CUI-based operating system is MS-DOS. Next up is the Command Line Interface, or CLI. In a CLI, the user communicates with the system through lines of text. The user types a command, and the system responds by executing that command and displaying the result. This interface is commonly used by programmers and system administrators due to its efficiency and control. Unix is an example of a CLI-based operating system. Last but not least, we have the Graphical User Interface, or GUI. This is the most commonly used interface today and is known for its visual appeal. In a GUI, the user interacts with the system through graphical elements like windows, icons, menus, and pointers. This makes it highly user-friendly, as it does not require the user to remember specific commands. Microsoft Windows and macOS are prime examples of GUI-based operating systems, but it's not just about aesthetics. GUIs also provide an intuitive way to interact with the system. For instance, to delete a file, you simply drag it to the trash bin icon. In a CLI or CUI, you would need to type a specific command to perform the same action. It's important to note that while GUIs are more user-friendly, they demand more system resources. CLI and CUI, on the other hand, are less resource-intensive but require a higher level of technical knowledge. In conclusion, each interface has its own strengths and weaknesses, and the choice between CUI, CLI, and GUI depends on the user's needs, skills, and the resources available. While CUI and CLI require specific commands, GUI has made operating systems more user-friendly. Why has GUI become so popular? Let's find out. Imagine yourself in a world where everything is text-based. You'd have to remember specific commands for every action, wouldn't you? That's where GUI, or Graphical User Interface, comes to the rescue. Its ease of use has made it a favorite among users worldwide. With GUI, you don't need to remember any complex commands, just point and click. Furthermore, GUI provides visual cues that make navigation seamless. Icons, windows, and menus replace the need for text-based commands, making it more intuitive and user-friendly. But that's not all. GUI also excels in multitasking capabilities. It allows users to run multiple applications simultaneously in different windows, enhancing productivity and efficiency. This is something that would be quite challenging in a text-based interface. In conclusion, the operating system is a vital component of a computer, managing hardware, providing an interface for applications, and enhancing user experience through GUI.